Okay, hi and welcome to this video on some logarithm properties and how to expand logarithms and simplifying a couple things that you will run across in Calc 1. And the first thing I'd like to actually look at is why do we even have logarithms in general? And so if we take a look at the example I just highlighted of 3 to the x equals 9, we could probably easily all look at that and say, well sure, x is 2. But if I change that problem to be 3 to the x equals 8, now we have an issue because that is not an exact rational nice number, and so we can approximate it and say that it's going to be close to 2, but we are going to need logarithms to bring down that exponent and be able to solve for the exponent when it is in, or when your variable is in the exponent. So let's take a look at some basic log properties that you should have seen in a prior course, and I've written them out for you here. The first one being that the natural log of the product, AB, becomes natural log of each one of the factors, or in other words, the sum of the natural log of each individual factor. And then as I continue on, I have natural log of A over B, and that would expand to natural log of A minus natural log of B, because truly if we look at it as a product, that would be B to the negative 1, which is going to make that a negative as seen below here. Natural log of A to some exponent M, we are able to bring this exponent down in front, and so that will become M times natural log of A. And hopefully all of these log properties were proved to you or shown to you in a previous course. And so what do we want to do with these properties? And I think before we go further, I'd like to give you one more that you will see as well, and that will be change of base. With our calculators nowadays, some people never actually know the change of base because we now have the new software that will sort of do this for us. But if I want to take a look and rewrite log base 3 of 5, I could say, for example, that that is log of any base, but we truly only want to use common logs, which would be base 10, or log base e, which would be a natural log. So I'll use natural log. So it's natural log of the tall, which is natural log of 5, over natural log of the small, or natural log of 3. And so this is just another way, and you can test this certainly in your calculator, of rewriting log base 3 of 5. So we'll need that as well. Okay, so as I'm looking through this, how do I use these? So one example might look like this. It might say expand, and let's say natural log of a square root. I'll put 1 minus x squared over 2 plus x. So let's say this was our job, was to expand this. And again, when you're in the pre-calc courses, you may not see the purpose for expanding this, and I hope that once you learn natural log derivatives in Calc 1, you will see a purpose for expanding this. So I'm going to make this as big with as many terms as I possibly can, but hopefully when we're done, each individual term will be very simplified. It will be non-complex. It'll look much better to work with for calculus. So first thing I want to recognize is that the square root is all to the half power, and everything is to the half power. So every single natural log that I have in my answer should have a half. So I can do that with parentheses, or I can just put a half in front of every single natural log term that I'm going to have. So this would be probably a first step, and I'm going to do this sort of step by step just so you can see. And then since the numerator is factorable, I will go ahead and do that. So I will say it's 1/2 times the natural log of, that factors into the conjugate pair, 1 plus x, 1 minus x, all over the factor 2 plus x. And I will now see that I have overall here a quotient, and so I will have 1/2 natural log of the numerator, and again I'm just going to go step by step here hopefully so you can see, minus, because this is in the denominator, 1/2 natural log of the 2 plus x. And hopefully along the way someone has also told you that the only thing you can truly distribute to a binomial is a number. I can never distribute functions like this. So I would never ever want to say natural log of 2 plus natural log of x. You're taking natural log of that value, whatever that value turns out to be. So I'll go one step further here. This is a product. This would be like natural log of a times natural log of b, natural log of a times b, which turns into 1/2 natural log of that a, plus, don't forget your 1/2 natural log of the b, and then minus the 1/2 of what was in your denominator. So now let's look at this, because I think that when you're doing natural log properties, you don't necessarily see, an application or a reason for having it expanded like this. Certainly you have a reason to combine or condense it so that it looks nice and neat like it did when it started. But let's take a look at each individual term, because now I have 3 terms, the first, the second, and the third here. So there's the first, the second, and the third. And if I look at them, each one should have the half because they were all under the square root in the beginning. And then further, each individual term is actually incredibly simplified. So if I look at it, when I learn natural log derivatives, I'm really just going to be working with that part, and I can take the derivative of 1 plus x very easily. When I do derivatives, I'm just going to be looking at this part for natural log, and again, I can take the derivative of 1 minus x pretty easily. And lastly, I would be looking at this argument of 2 plus x, and again, I can do the derivative of that fairly easily. So each individual term is very simplified, and this will take away the necessity of 4 or more rules in one problem. This will also potentially take away your necessity for things like quotient rules and chain rules and things like that, and it will help you out. So I hope you found that helpful with natural logs. I think that's all I have to say for now on that.